Today we are going to see the properties of square numbers. Property number 1. A number having 2, 3, 7 or 8 at units place is never a perfect square. In other words, none of the square number ends in 2, 3, 7 or 8. Let's see the pattern of the square numbers. The 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. It goes on like this. But if you see the number at the units place at the square number, it ends with either 1, 4, 9, 6, 5. Again the numbers are getting repeated: 6, 9, 4, 1, 0. So by looking at this pattern, we can conclude saying that all the square numbers are ending with 1, 4, 9, 6, 5 and 0. So from this one we can say if the square number ends with 2, 3, 7 or 8, this is not going to be the square number. So we can say that always the square numbers are ending with 1, 4, 9, 6, 5 or 0, and it is not going to end with 2, 3, 7 or 8. Property number 2. The number of zeros at the end of a perfect square is always even. Remember that if a square number ends with 0, it will always have even number of zeros. For example, 20 square is 400, 30 square is 900, 100 square is 10,000. Look at all these numbers. 20 square has 2 zeros at the end of the number. 30 square has again 2 zeros, and 100 square has 4 zeros. So 2 zeros is also even number, 4 zero is also even number. From these numbers we can conclude that number of zeros at the end of a square number is always even. Property number 3. The squares of even numbers are always even and square of odd numbers are always odd. Example number 1, it is 12 square. 12 is an even number and the 12 square is 144. That is also an even number. Next one is the odd number square. 13 square is 169. 13 is an odd number and 169 is also an odd number. From this we can conclude that if we square an even number, we are going to have the result in even number, and if we square the odd number, the result is going to be in odd number. Property number 4. The square of a natural number other than 1 is either a multiple of 3 or exceed a multiple of 3 by 1. In other words, a perfect square leaves remainder 0 or 1 on division by 3. Let's take the perfect square number 36. When we divide it by 3, we get the remainder as 0. And then the square number 49, we divide by 3, it leaves a remainder 1. Similarly, for the number 16, when it gets divided by 3, leaves the remainder 1. Similarly, 25, it leaves the remainder 1 on division by 3. So you take any square number and divide it by 3, we always get remainder either 0 or 1. Property number 5. The square of a natural number other than 1 is either a multiple of 3 or exceed a multiple of 4 by 1. In other words, we can say take any square number, divide it by 4, we get a remainder as 0 or 1 always. For example, take the number 36. We get a remainder 0 when it gets divided by 4. So this is the one of the property that says that take any square number, divide it by 4, it leaves the remainder either 0 or 1. Property number 6. The units digit of the square of a number is the units digit of the square of the digit at the units place of the original number. To explain this property, let's take an example. 13 square. What is the unit digit of this 13? That is 3. What is the square of 3? 9. So, the square number will have the square of the unit digits of the original number. Here the square number is 169. This 169, this 9 is the square of the unit digits of the original number, that is 13. Let's take an example of 12 square. What is the unit digit of the number 12? 2. 12 square is 144. Here number 4 is the square of the unit digit number 12. This square is the square of the last digit number. Property number 7. There are 2n non-perfect square numbers between the square of the numbers n and n plus 1. For example, let's take n is equal to 5 and n plus 1 is equal to 6. So, between this 5 square and 6 square, that is equal to between 25 and 36, there will be 2n non-perfect square numbers. So, 2 multiplied by 5, that is equal to 10 non-perfect square numbers between 5 square and 6 square. Those numbers are 26 to 35. Property number 8. Sum of first n odd numbers is n square. Here first odd number is 1, that is 1 square. First sum of the first two odd numbers, that is 1 plus 3, that is 2 square. Sum of the first three odd numbers, 3 square. Sum of the first four odd numbers, that is 4 square. So, sum of the first 5 odd numbers will be 5 square. Here, these are the consecutive odd numbers, that is first 5 odd numbers, that is 5 square, that is equal to 25. So, we can write 5 square as sum of the first 5 odd numbers. 6 square as sum of the first 6 odd numbers. Property number 9. For any natural number m greater than 1, 2m, m square minus 1, m square plus 1 is a Pythagorean triplet. What is a Pythagorean triplet? A Pythagorean triplet consists of 3 positive integers a, b and c such that a square plus b square is equal to c square. So, let's take any number that is greater than 1. In our case, it is 2. Then 2m, that is equal to 4. M square minus 1, that is equal to 2 square minus 1, that is 3. And m square plus 1, that is 2 square plus 1, that is equal to 5. So, 4, 3, 5 are the Pythagorean triplets. So, let's see the summary of all the properties that we have seen so far. A number having 2, 3, 7 or 8 at units place is not going to be a perfect square. The number of zeros at the end of the perfect square is always even. The square of even numbers are always even and square of odd numbers are always odd. The square of a natural number other than 1 is either a multiple of 3 or exceeds a multiple of 3 by 1. The square of a natural number other than 1 is either a multiple of 4 or exceeds a multiple of 4 by 1. The units digit of the square of the number is the unit digits of the square of the digit at units place of the original number. there are two non-perfect square numbers between the square of the numbers n and n plus 1. The sum of the first odd numbers is n square. For any natural number m greater than 1, 2m, m square minus 1, m square plus 1 are the Pythagorean triplets. Now let's see some quiz related to the properties of square number. First one is find out whether the following numbers are square numbers. First one is 1057. The units digit is 7. Here the square numbers never ends with 2, 3, 7 or 8. So this is not the perfect square number. The second one, it ends with 0. All the square numbers will end with even number of zeros. Here it is odd number of zeros, 3 zeros, so it is an odd number of zeros. So this is not the square number. Now let's see the second. Square of even number is always, yes, it is even. Square of odd number is always odd and even number is even. Third one, what will be the remainder when the square number is divided by 3? Yes, the remainder will be 1 or 0. Next one, what will be the remainder when the square number is divided by 4? Take any square number, example 25 divided by 4, we get the remainder 1. So the square number always leaves the remainder 0 or 1 when it is divided by 4. What will be the units digit of the square of the following numbers? Here the original number has unit digits as 6. So the square number will have square of this unit digit, that is 36. So the square number is going to end with 6. How many non-perfect square number will be between 5 square and 6 square? We have seen in the properties that there will be 2n non-perfect square numbers between n and n plus 1 squares. So that is 2 multiply 5, that is equal to 10 square numbers. We are going to have 10 non-perfect square numbers between 5 square and 6 square. Without adding, find the sum of these numbers. We have seen in the property that sum of the first 2 odd numbers is 2 square, 3 odd numbers is 3 square. It goes on like this. Here it is sum of the first 8 odd numbers, that is equal to 8 square. Hence it is 64 is the answer. Check for Pythagorean triplet when m is equal to 2. When m is equal to 2, 2m, m square minus 1, m square plus 1 are going to make the Pythagorean triplets. Here 2m is equal to 4, m square minus 1 is equal to 3, m square plus 1 is equal to 5. So 4, 3, 5 are going to be the Pythagorean triplets.